Okay, this is the Unit 10 review. So if you haven't filled in your study guide yet, please don't watch the video. Stop it, get your study guide filled in, and then come back to check your answers. All right, so it wants us to show two different ways that we could extend this particular pattern. One is to just literally duplicate it. Sorry, I had my pen picked there, like so. So we went back to just taking the triangle, square, triangle, triangle. So you end up with 3 triangles in a row. The other way is to assume that this triangle here is the one that's here, and then you would start with square and go triangle, triangle, and then have square again. So there are always multiple ways to extend a pattern if you're not given enough terms of the pattern, so just keep that in mind. The next one is a shrinking pattern. Okay, we know this because the shape gets smaller, right, between each increment. They take one off top, one off bottom, one off top, one off bottom. Okay, so that's how we know it, and that was the rule. So my next shape for this pattern would be just a long rectangle, right, that had the increments inside of it. Let's see, there are still 1, 2, 3, 4. I think that's how many there are, is it? One more. Sorry, let me move these up. And then it would have a foot on the here we go. It would have another foot if we went top, bottom removed, top removed, bottom removed, top removed, bottom removed. It would have another one right across here. So you would just have your extra little piece that goes here. Okay? So that's kind of what it would look like. Sorry about my wonky drawing. Okay? So we've done number 4. 2 different ways to extend this next pattern, right? You could go another 1/8, 1/4, 1/8, and then it would be 1/8 again. Or you could go 1/8, 1/4, and they just go every other, like A-B pattern, 1/8, 1/4, so on. Okay, so a couple ways to extend those. Write the equation that represents this function table. You guys have gotten fairly good at those. So just think about, how do I get from C to D, and then come up with your rule. So you can start with number 1, you can start with number 2, just whatever number you see that's going to help you get your rule drawn. Okay. On this particular one, it's rule. Its rule is D equals E equals 2C plus 4. Okay. All right. On this one, it's got a locked point here at Z. So you could say if this was my original, it's had a 90-degree rotation clockwise. 90-degree rotation clockwise with Z locked. As a fixed point. All right, because Z didn't move. Okay. Okay, next page. If we look at what the number represents here, what happened with the parallelogram, it moved across the x coordinates 6 positions. Okay. So if my original one was PQR, which is this triangle over, or sorry, parallelogram over here, when it moves over, it's moving a -6. It's moving 6 less positions, 6 less, okay, than the original. But on the X, that was on the X. The Y, oops, stays the same. That is not the word they. Let me erase so that you don't think it's a they. The Y stays the same. the y stays the same. Okay, so my y values don't change. Okay, on this next one, if I am to reflect, remember a reflection is going to go across the line. So I go across, this would be a transformation along a line. This is a reflection across the line. So if I reflect across, I should have one gap between the two. So notice my new coordinates are 6, 2, 6, 9, 9, 2, and 9, 9. Okay. On my last one here, if I drew something out, and you can see all my bits and pieces are over here, so I'm just going to kind of move them across. First, I need to plot the points 1, 8 to 15, 8. So 1, 8, 15. Let's see, did I do that right? Oh, this is my long line, 1, 8 to 15, 8. I need my longer line. That's my problem. 1, 8 to 15, 8. Okay, so it would look like this, and that's the line that I'm going to reflect across. So I'm going to draw a triangle then, or sorry, a rectangle then, that goes 4, 3, 4, 3, get my points, 4, 3, 4, 5, 4, 11, 3, 11, 3, and 11, 5. And then I can make my actual rectangle. And then as I reflect it across, okay, it's going to end up in a different location. So here's my original as it describes. And then I'm going to take that and I'm going to reflect it across. So it means to end up in the exact same spot, the same number of positions away. Okay. All right, 1, 2, 3, 1, 2, 3. Yep. Okay. So here. I'm just putting those pieces together, and then I'm going to describe my new coordinates. Okay, so my new coordinates are going to be, I reflected the rectangle, and my coordinates are 4, 11, 4, 13, 11, 11, and 11, 13. Okay, so just think about reflections, transformations, slides, and all of those things.